Now, on the next ones, we're still working with not just polynomials, but all kinds of functions. So on 24 through 27, we're supposed to find the zeros and the domain. So I want to talk about that, especially when we have a fraction. Zeros are going to be when the numerator is 0, and the domain is going to be when the denominator does not. Now, also square roots come into that effect for domain. So let's just start with our zeros. Zeros are when the numerator is 0. So the zeros would be when the square root of x equals 0, which would be when x is 0. True. Now the domain, I've actually got two things going on here, so I should have thought about that before I spoke. I have to worry about the denominator not being 0, and the square root has to be positive. So there's a couple of things in the domain. 2x plus 1 cannot be 0. And the square root has to be greater than or equal to 0. So x has to be greater than or equal to 0. So here, x is not going to be negative 1/2. And x has to be greater than or equal. Well, if x is greater than or equal to 0, is it ever going to be negative 1/2? No. Now, depending on how they write the answers, it could be written either way here. But either one of those does not include negative 1/2, so we're good there. 25. Zeros. Well, this one's easy. The zeros are just when x plus 5 equals 0. That's negative 5. Now, do we have any fractions or square roots or anything like that? Nope. So it's all real numbers, or negative infinity to infinity. Number 26. F of x equals the absolute value of x plus 2. So for the zeros, that's when y is 0. So absolute value of x plus 2 equals 0. So the absolute value of x equals, can an absolute value be negative? No, so there are none there. Woo. Now the domain. Do I have any fractions or square roots? Well, the domain is all real numbers. It's just not hitting the x-axis. Zeros. It's when y equals 0. So that's when the square root of 16 minus x squared equals 0. That's when 16 minus x squared equals 0. When 16 equals x squared. So x equals plus or minus 4. Now the domain. What's underneath the square root has to be greater than or equal to 0. So negative x squared has to be greater than or equal to negative 16. X squared has to be less than or equal to 16. Let's think about what that would make that true. So 0, 1, 2, 3, all the way up to 4. But also negative 4, negative 3, negative 2, negative 1. So this is everything from negative 4 to 4, or you could write it as negative 4, comma 4. Now in 28 and 29, we're talking about intercepts and asymptotes. Now, what would make this one a lot easier is if we factored. And I know most of you like to do the slide and divide. That'd be 8 and 3 divided by 2. So I get x minus 4 and 2x plus 3, right? In the denominator, I'd have x plus 4 and x minus 4. Now remember, the x minus 4s canceling out would actually create a hole. So we actually have a hole at x equals 4. Now let's talk about what we have left. 2x plus 3 in the numerator. That's actually going to give me my x-intercept. Now my y-intercept would be when x is 0. So I'm going to go back to this. Well, I could go here too. When x is 0, I have a 3 left and a 4 left. It's 3/4. Intercepts are easy. Now, vertical asymptote and horizontal asymptote. The vertical asymptote is going to be with what's left in the denominator, so x equals -4. And the horizontal asymptote, since we have the same degree, 2x squared divided by x squared is 2, so y equals 2. Number 29. G of x equals x squared plus 2 over x minus 1. Now, x-intercept would be when the numerator equals 0. And that's never going to happen. Now, the y-intercept is when x is 0. So I get 2 over -1. Y equals -2. Now let's talk about our vertical asymptote would be at 1. And we would not have a horizontal asymptote. What we would technically have is a slant asymptote. It would be what I get if I divided x squared plus 2 by x minus 1. I don't think I saw anything like this on the exam, but I'm going to go ahead and talk about it. So if I divided x minus 1 into x squared plus 2, I would have an x, then subtract, that'd be a positive 1x plus 1. Now the remainder won't matter. My slant is going to be what's our divisor up there, just the x plus 1. I don't think that was on the exam, but I wanted to cover it just in case. Okay, now number 30. We're finding the inverse. Now to find an inverse, we're going to switch x and y. So f of x is another name for y. So I get x equals 2y plus 7. Now solve for y. Do another inverse. Switch x and y. Now, if I'm trying to solve for y, I've got to square both sides. Then add 1. Then divide by 3. So my inverse would be x squared plus 1 divided by 3. Now, the last one in this section is adding, subtracting, multiplying, and dividing. Easy stuff. So on 32, we are given f of x equals x squared minus 3, and g of x equals 4x plus 5. On part A, we're taking f of x plus g of x. So you're literally taking f of x plus g of x. You're just going to combine like terms. On B, we're subtracting them. So I do have to be careful here because I'm subtracting all of g of x. So it'd be minus 4x and a minus 5. C is f times g. What that means is I'm going to take f of x times g of x. I'm going to FOIL it. I'm going to distribute. X squared times 4x is 4x cubed. Then I'd have plus 5x minus 12x minus 15. D, f of x over g of x. And it does say to give the domain here as well. Well, when I have a fraction, I do have to be concerned about domain. 4x plus 5 cannot equal 0. So 4x cannot be negative 5. X cannot be negative 5 over 4. We do need to include that as part of the answer.